Okay, 6th grade, lesson 111. This one is on applications using division. All right, so watch me. There are 3 different ways to do this problem. See that? And I'm going to show you all 3 different ways. Okay? Let's do that one with blue in the middle so it'll break them up a little bit. If I had 3 colors, I would do 3 colors. But I don't. Okay, so let's do this. All right, the first way is we're going to come up with a remainder. So help me do this one. What would 4 times what equals 15? The closest without going over. 3 probably, right? 4 times 3 is 12. 4 times 4 is 16.
Yeah.
So that went over. So 3. 4 times 3 is 12. And we get 3 left over. So in the very beginning, when you started doing math, the way you did this is put 3, remainder 3. Do you remember doing that? That was your very elementary learning how to divide. Okay, then you learned this next way. 4 times 3 is 12. You subtracted that and got 3, and you took this number, brought it up to the top, and brought this 4 over. Remember that? That was the second way you learned how to do this kind of problem. So everyone takes it a little step further. Okay, so this one gives us a mixed number. This one gives us a number with a remainder. And then the last way, ready, we're going to do that one together. 4 times 3 is 12, and we get 3 left over. Now, what's the newest way you just learned? Do you remember?
I think you do like 3 squared or something like that.
No.
I don't know.
It's where you put a decimal. Remember, the decimal's at the end of a number, even if you can't see it. So it's at the end of that number, and what do I add here?
Oh, yeah.
You remember that? That's very new learning. So, okay. So I put a 0. I'm going to bring that one down. Okay. 4, we're going to 30.
5.
5 times 4 is 20, so we have to go higher. 7 times 4 is 28.
Yeah,
8 times 4 is 32. So it'll have to be 7 because it'll go over if we do 8. So then we get 28. And we get a 2. Okay, I'm going to add another 0, bring it down, and I get 20 down here. So now 4 goes into 20 how many times?
5.
5. Okay, and so I don't have much room, but there's a 5 right there. Okay, now I'll move my decimal up, and my answer is 3.75. So I'll put that up here so we can see it better. Okay, so this is my third answer. So everyone takes this a little bit further to understanding it better. Okay, so this is, they're all 3 the same answer, just written differently. Do you get that? Okay, so we are going to take a word problem and decide, should I break it up like this? Should I break it up like this? Or should I break it up like this? Okay, and you'll understand when you see the problem. Okay, so I'm going to write down, what were the 3 ways?
Remainder.
Remainder is one of the ways.
You can make it a mixed fraction.
Mixed number is the next way. And the third way is
you'd add a 0.
decimal number.
Yeah.
Okay, those are the 3 ways that we can do a problem. So, ready to listen to this problem? 100 campers. Set that down, please. 100 campers are to be assigned to 3 campsites. So let me draw a visual of what that looks like. I have 100 people, okay? And we're going to 3 different campsites, all right? How many campers should be assigned to each campsite so that the number are as balanced as possible? What am I going to have to do?
Divide it by 3.
Divide what?
100.
Okay, very good. So we're going to take 100, divide it by 3, and let's just go on and do some of the math. 3 times
33 and 1/3, I think.
is 9. You're right. Okay. And so then I get a 1. I bring down that 3, 9. I get 1 left over. So, should I use the remainder method? That's telling me that each cabin should have 33 in each one, and then I have a remainder of 1 more person. And I can put it in this cabin, I can put them in this cabin, or I can put them in this cabin. Do you think this way tells us the best?
No.
Why not?
Well, because you could do the decimal thing, I think.
Well, if I did a decimal, how can we get half of a person? You see? Because if I had a decimal, then let's add another 0. And that would be 3. And so that would be 33.3. And I can't take a third of a person and put them in a cabin.
Yeah.
See that? So that's good, though, because we're able to see that now that we did it. Okay, and if I did it the other way, where I brought the 1 up and the 3 over, can I take 33 and 1/3 of a person?
No.
No. So the best way is using our remainder system. So the first one would have been this one, because we can just, okay, I've got remainder of 1 more person, and I'm going to just put them in cabin A. See?
Mm-hmm.
So this cabin would have 34, this one have 33, and this one have 33. And that's the best balanced out system that we can come up with. See that? Okay, so everything's really just trial and error. You have to think to yourself, if I did it that way, I can't really do that. So, all right, let's move to the next one. All right? So far, the remainder is winning. Okay? Movie tickets cost $4. I don't know where this is because they sure don't cost that much now, or that's that little now. Jim has $15. How many tickets can he buy? So what am I going to do?
Divide it.
Okay, $15 divided by 4.
Mm-hmm.
Okay, 4 times 3 is 12. I get 3 left over. Okay, so we can either have 3 remainder 3, 3 and 3/4.
I think decimal would work best because
Or-
it's money.
3, let's put a 0, and that one ends up being 3.75, I think. Yeah.
Yeah.
So we get 3 remainder 1. That's one of our choices. This is our second choice, and this is our third choice because we've already done kind of this problem. Okay, so it's asking, here's the question. How many tickets can he buy?
Well, 4, 8.
Can you buy 3 and 75?
Probably 3 of them.
3 tickets. So this one, again, the remainder helps us because we're wanting to know how many tickets. If we were talking about money, how much money did he spend or something like that, it would probably be best to do it decimal.
Mm-hmm.
So because we're asking for tickets, we can't buy 3 and then 75ths of a ticket.
Yeah.
You either just have 3 or buy 4. Okay? Here, again, you can't buy 3 tickets and then 3/4 of one of the tickets. And here, we can buy 3 tickets and we still have $1 left. So this is probably the best way.
Yeah.
So, again, the remainder won. So, he bought how many tickets?
3.
Very good. All right. Question number 3. So far, remainder is winning. 15 children need a ride to the fair. Each car can transport 4 children. Each of them holds 4 of them. Okay? So, how many cars are needed to transport 15 children?
You divide. Wait, how many cars do they have?
Well, that's what they're trying to figure out. How many cars do we need?
Oh, okay. Divide it into 4.
Okay, 15 divided by 4. 4 times 4 is 16, so let's do 4 times 3. Gosh, we're using this problem a lot. Okay, so I have a remainder 3. So, what they're saying is we need to have 3 cars. With that one's 4 in it. Another car with that one 4. 4, 4, and 4 makes 12. And then I have another car. How many is this one going to have in it? 4, 4, and 4 is 12. 13, 14,
3.
15. Okay, so they told us that the car can hold up to 4. So we couldn't put 5 in here.
It's remainder again.
So, yeah, we know that we need 3, and then we have 3 people left. So, there you go. So, how many cars do we need?
3, 4.
4. Yes. So this one kind of helped us, but we had to round up because actually the best way is to go 3 and 3/4 maybe. No, because that's really half of the car. So 3 remainder 3. We still have 3 people left. So we know that we need to have 4 cars because 3 only got us majority of them. But we still have 3 people left. Gosh, the remainder is being used a lot. Okay, let's try the last one. All right, last one. 4 workers were paid a total of $50. So I have 4 people. They got a total of $50 between the 4 of them for cleaning a yard. If the workers divide the money up equally, how much money will each worker receive?
Divide 50 by 4.
Very good. 50 divided by 4. 1, 4 times 2 is 8, 9, 10, 2. Okay.
And you're going to add a 0.
You're going to add a decimal and add a 0 because we are working with money and they want to know how much is paid. Money is always best with decimal. Very good. 4 will go into 20 5 times. And that evens it out. We're done. Move the decimal up.
$12.05.
Nope. What spot is that in?
Oh, that's in the ones, I think?
No, tens,
Tens,
hundreds. So what would we fill right here?
0.
Fill it in with a 0. Okay, because 5 tens, this is the 10 spot.
Yeah.
5 tens make 50 cents. Okay? So, how much does each person get?
$12.50.
Very good. So, decimal 1 on that one because we're dealing with money. Okay? I guess you probably could have done mixed number on one of them, but not really. I like the remainder method if we're doing that. Okay? Another way to go is if a good mixed number problem would have been something like this. Johnny had some string, and he had 15 inches of string. So let's pretend like this is a 15-inch string. And there are 4 people that are wanting to make a bracelet. How much does each person get?
You divide it by 4.
Right. So 4 times 3, we're still got the same number again. Okay, and this is where it would be helpful because I bring the 3 up and 4. So everybody gets 3 inches and then 3/4 of an inch. So everybody would get 3 inches and then 3/4. 3 inches and then 3/4. 3 inches and then 3/4.
Yeah.
So that would be a good example of what a mixed number one would look like. They didn't actually give us an example on here. Got it?
Mm-hmm.
That's lesson 111.